Okay, so tomorrow you have the Chapter 6 test. The test will have 14 questions on it. There are no proofs. There are no sometimes, always, or nevers. It's mostly applying the theorems and the definitions and the converse, know how to find the points of concurrency, know how to find the lengths of things, how to find the value of x. So I believe the test is pretty straightforward. There are 3 multiple choice questions, and I'm going to tell you what the answers are right now. So answer choice A, and I don't know if it's in this order or not, is greater than, B will be less than, C is going to be equal to. So you're going to have 3 questions where these will be the choices. So obviously you're going to be comparing angles or sides just like we did in the 6-6 warm-up. So only 3 multiple choice questions, and these are the 3 answers. So it's that basic. The rest are all fill-in, where you're finding an x or you're finding an angle measure. Or I may even ask you, order the angles from greatest to least or least to greatest. If I ask you to do that, make sure you're reading it. Because if I ask you to order the angles of a triangle from least to greatest and you give me greatest to least, you just lost. Okay? So read the questions carefully. Let's go through the review. Now, remember, the review doesn't cover everything. For those of you who already did the review, notice there were no questions where you had to use the centroid. And the centroid was that 2/3, 1/3 part. So make sure that you understand how to do that. It was on the quiz. I'm going to give you back the quiz and be able to do those calculations and find either the whole segment or the 2/3 portion or the 1/3. There aren't questions where I ask you to order things least to greatest. So remember, don't just focus on this review. Go back. The warm-ups are an excellent resource, as well as your notes and the homework. So let's go ahead. I'm going to work out all 18 questions. I'll try to go through them rather rapidly, so then we'll have time to get back the quiz and review it. And then I can also take any other questions you may have. Now, I also have a GIM kit. I don't know if we'll get there or not, but if we do, we'll play it. If not, I will post the link. All right, so for number 1, this is where we learned in 6-1 about perpendicular and angle bisectors. But if you notice here that in my picture, I've got some congruency marks. And this tells me that point B is equidistant from the endpoints of segment AC. So I can tell that AC, that BD, is a perpendicular bisector. And I know that these two, since BD is a bisector, I know that D is going to be the midpoint of AC. So these two sides are equal. Now, this question did not ask me to find X. It just asked me to find DC. So if AD is 20, so is DC. This one really didn't involve any work. Now, if the question on the test says instead, find the value of X, then you would have had to set 7x minus 15 equal to 20. Add the 15. 7x equals 35. Divide. And then x equals 5. So if it asked for x, that's what you would have done. But if it just wanted that measure, we didn't have to do anything because they had already given it to us right here. Now for the next one, they're not giving us the length of that equidistant segment, so I have to find x on number 2 and then plug it back in to get the length of RS. And the reason why I know that these two segments here in blue are equidistant to the sides of the angle, I can tell that this angle here was bisected. So when I have an angle that is bisected, I know that any point that's on that angle bisector is going to be equidistant from the sides of that angle. So these two segments are equal. So to solve for x, I'm going to set 9x minus 4 equal to 6x plus 5. I'm going to find x by subtracting 6x. and I get 3x minus 4 equals 5. Add the 4. 3x equals 9. Divide by 3, and x equals 3. Now, it didn't ask for x. It asked me to find the length of RS. RX is right here. It's the 9x minus 4. I'm going to plug in 3. I'm going to multiply and then subtract. So the length of RS is 23. Now, to find the measure of GFH, here I can see that I have equidistant segments to the sides of the triangle, or the sides of the angle. So I can tell that this angle here, GFH, this one right here, has been bisected. So then I know that this side would also be 47, which is what they had asked me to find. So 47 degrees. Now, if they would have asked for the measure of angle GFH, then I would have had to have added 47, 47, and gotten 94. So be very careful of what the question is asking you to find. Then for number 4, this is where we learned about the points of concurrency. Now, when you were working on this in class on Wednesday, I told you that after you graph the 3 ordered pairs, if it created a right triangle, then I wanted you to find the circumcenter. Because tomorrow, if I give you a question and I ask you to find the circumcenter, remember when it's a right triangle, it will be on the triangle and its location is going to be the midpoint of the hypotenuse. So I will only be giving you a right triangle if I ask you to find the circumcenter. If I asked you to find the circumcenter of an acute or an obtuse triangle, that gets a little bit more challenging, and it's really more beneficial when you have actual tools like a ruler to find it. So I will only ask you for a right triangle circumcenter if you get that version of the test, and notice that it is located at the midpoint of the hypotenuse. So I'm going to go ahead and graph number 4 because number 4 was a right triangle. So for number 4, I'm going to graph it. I'm just going to do a rough sketch. Now, on the quiz, when I gave you a question like this, I had asked you I gave you graphs. I told you the graphs were optional. On the test tomorrow, I'm not giving you a graph like I did on the test. What I've done instead is I've attached a piece of graph paper to your test. That piece, that last page of your test, is going to be your scratch paper. You can go ahead and pull it away from the staples, and you can use that as your scratch. One side has graph paper, the other side is blank. So for any of the questions where you're asked to find the point of concurrency and you want to graph it, I'm giving you the graph paper. You don't have to. If you can figure out which 2 points you need to find the midpoint of, then you don't have to graph it. So let me go ahead and graph these ordered pairs. I'm going to graph ordered pair T. It's 6, -5. So it's over here. And then U is 0, -1. And then V is 0, -5. So when I connected my points, I saw that I had a horizontal and a vertical line. And I know when a horizontal and a vertical line intersect, they're perpendicular. So I have a right angle right here. So then this tells me that the side across from the right angle is going to be my hypotenuse. Now, I could go ahead and draw in the perpendicular bisectors. Technically, what you would be doing is finding the midpoint of each side, and then you would connect and draw in the perpendicular bisector from that midpoint to the side opposite. And here is going to be my point of concurrency. It's going to be -3, -3. But my advice to you is do the calculation for the midpoint. I'm going to use points U and T, and my point for U is 0, -1. T is -6, -5. I'm going to calculate that midpoint. 0 plus -6 divided by 2, -1 plus -5 divided by 2, -6 divided by 2, -6 divided by 2, and that gives me -3, -3. So you could either choose to graph it and draw in the perpendicular bisectors and find the point of concurrency, which again, remember, when it's a right triangle, it's always on the triangle, and that place on the triangle is going to be the midpoint of the hypotenuse. Now, number 5, once you graph them, you would have found that this was not a right triangle, and you could have stopped there. For number 6, the figure over here on the right of it is the figure they're asking us to use. They're telling us that point D is the incenter, and I know that the incenter is the point of concurrency of the angle bisectors, and I know from the theorem that from that point of concurrency, I can draw equidistant segments to each of the sides. So each one of these blue lines, RD, SD, and TD, are all equal, so the value of X is 5, because they're all congruent segments. These are not the perpendicular bisectors, they're the equidistant segments from the incenter. Next, 6.3, this is where we learned about medians and altitudes. So if I give you a question and ask you to find the centroid, remember the centroid is always located inside, so it doesn't matter the type of triangle I give you. All you need to do is either find the medians and find their point of intersection after you draw them in, or use the trick. Add the x's, divide by 3, add the y's, divide by 3. So I'm going to, on number 7, I'm going to take all of my x's here. I'm going to add them. -10 plus -4 plus -4, divide by 3. And then do the same thing with the y's. Add them, divide by 3. The blue gives me -18, divide by 3, so that'll be a -6. The red gives me 9/3, which gives me 3. So the coordinates for my centroid on number 7 are -6 and +3. Then for number 8, I will do exactly the same thing. I'm going to add the x's and divide by 3, add the y's and divide by 3, and this is going to give me the coordinates for my centroid by just doing the trick. Again, you could find all the midpoints, draw on all the medians, and then find their point of intersection. However, it's a lot easier to just take all the x coordinates, add them, divide by 3, and the y's. So let me go ahead and do that with my x's and my y's here. So for number 8, I'm adding 2 plus 2 plus 8, divide by 3, 12/3, which gives me 4. And then my y's, -8 plus -2 plus -2, -12 divide by 3, and that gives me -4. So the point of concurrency, my centroid, is the ordered pair +4, -4. And then for number 9, now for the orthocenter, just like the centroid, I'm only going to give you a right triangle if I give you this question. So remember, when you're looking for the orthocenter, when it's a right triangle, it's on the triangle, and it's going to be located at the right angle. So again, you're going to have that graph paper. You can graph it to see which ordered pair of the 3 is the right angle, and then that will be your answer. On this review, questions 9 and 10, these were not right triangles, so all you were expected to do was graph them. So number 9 was an acute triangle, and number 10 turned out to be an obtuse triangle. So again, you did not actually have to pull out your ruler and find those orthocenter? If you did, the orthocenter for number 9 was the order pair 3, and then 26 over 5. And then the order pair for number 10, that orthocenter was -6, -1. Again, I will not give you an acute or an obtuse triangle tomorrow. Then for 6-4, this is where we learn the mid-segment theorem. And remember, the length of the mid-segment is always half as long as the side of the triangle it's parallel to. However, to find the vertices of the mid-segment triangle that is created is you find the midpoint of each one of the 3 sides of the original triangle. Once you find those midpoints, then you connect them, and then that becomes your mid-segment triangle. So for number 11, I'm going to go ahead and find the midpoints. And again, here's where your graph paper will come in. If you want to graph the 3 order pairs to figure out the 3 sides that you need to find the midpoints for. I'm actually going to find the midpoint of AB, AC, and BC. So the midpoint of AB, I'm adding -6 plus -6 divided by 2, and 8 plus 4 divided by 2. -12 over 2, 12 over 2. The midpoint and my first vertice is -6, +6. Because again, the vertices of that mid-segment triangle are the midpoints of the 3 sides of your triangle. Then the midpoint of AC, I'm going to be adding -6 plus 0 and 8 plus 4. -6 over 2, 12 over 2, -3, +6 is my next vertice. All right, and then the last midpoint we need to find is BC. So again, I'm going to add -6 plus 0 divided by 2, 4 plus 4 divided by 2, -6 over 2, 8 over 2, -3, 4. So these are the 3 vertices of the mid-segment triangle. It's just the midpoints of the 3 sides of the original triangle. You'll do exactly the same thing for number 12. You're going to find the midpoints of the 3 sides. So for number 12, you need to find the midpoint of DE, which is 0, 3, the midpoint of DF, which will be -1, -2, and then finally the midpoint of EF, which will be 2, 0. And then that will form, once you connect those midpoints, forms your mid-segment triangle. Okay, next we talked about indirect. We did not talk about indirect proof. You will not have that on your test. Again, no proofs on the test. We did learn the inequalities in one triangle. So this is where we were shown that you're going to add and subtract the 2 smaller sides of the triangle. And then that third side must fall in between that sum and difference. It must be greater than the difference, but less than the sum. So for number 13, to get my inequality, and you will have to write it as a compound inequality tomorrow, you're going to take the 2 numbers they give you, and if they give you 3, you're going to take the 2 smaller ones. So here I've only been given 2, so I just take the 2 they gave me, and the third side must be greater than the difference, but less than the sum. If I give you 3 numbers and I ask you, will these 3 numbers form a triangle? You're going to add and subtract the 2 smaller numbers, and if the largest side falls in between that sum and difference, then your answer is yes, it will form a triangle. We did this in the notes. The questions on the test will say explain. Your explanation will be your work, showing me how you added and subtracted, and if that third side fit in to this inequality. Then number 14, same thing. Add and subtract the 2 numbers. And again, if I give you 3 numbers, you choose the smaller 2. So because this is my range of values. Now, let's say the third side that I gave you, let's say this question said, will these three numbers form a triangle, 6, 9, and 10? This answer would be yes, because 10 falls in between the sum and difference. And that's how you would explain it. Same thing, add and subtract them. So for 15, 11, and 18, add and subtract them. 29 and 7, you're going to write it as a compound inequality. So x has to be, the third side has to be a number between 7 and 29. And then the last two questions, all you're doing is comparing the side lengths like we just did in the warm-up. So here, we're using our hinge theorem. So we know that we're comparing this angle here and this angle right here. So they're giving us, actually they're asking us to compare QT and ST. So I need to figure out which symbol is going to go in between here, greater than, less than, or equal to. But they told me that angle QRT, this one, is the bigger angle. So this tells me QT is the bigger side. So QT is greater than ST. And then in 18, they're telling me that QT is the bigger side, and now they want me to compare angle QRT to angle SRT. Well, since I know that this side is the biggest, then I know it's across from the biggest angle. So angle QRT is greater than angle SRT because the side across from it is the bigger side. So again, there is another review that is posted on Canvas. It does have the solutions. You do not have any homework tonight to submit. Your homework tonight is to study. Again, remember, don't just focus on this review. It's a good place to start, but remember, you should also go back, use your warm-ups, use your notes, use your homeworks. Use all of those resources to get you ready for tomorrow's test, whereas most of the questions are free response, and there's 14 of them.